there you go. I think I'm live. Okay, so grab a good pen and let's start. It is June 10th. Wow. So our objective today really is we are going to graph sine and cosine curves, and we're going to modify amplitude and period. Okay.
What amplitude is?
Amplitude is how tall, and the period is how wide. Okay. Amplitude is how tall, and period is how wide. Let's write that down. Amplitude is like height, and period is the width. Okay, example number 1. If we're going to graph y equals sine, 3 sine of x, then I'm just going to take my sine, my standard parent sine function, and the only thing I'm going to do is increase its amplitude from 1 to 3, from -1 down to -3. That's all I'm going to do. So when I start this, I'm going to put down these. Every 4 squares, I'm going to go pi halves, pi, 3 pi halves, 2 pi, okay? Start there. And those are just the angles. These are angles, because this is theta. These are just the angles, the important angles from the unit circle. 0, pi halves, pi, 3 pi halves, and back to 2 pi, okay? I also like to put in the pi force, 3 pi force, 5 pi force, 7 pi force. So I have all the important angles on my circle. Now, it has an amplitude of 3. So I'm going to go 1, 2, 3, -1, -2, -3. Okay? All right. My sine curve that we took down as the parent function looks like this. I'm going to put this exact curve on my graph, except for I'm just going to stretch it up to pi halves and down to -3 at 3 pi halves, okay? So I stretch this one at pi halves up to 3. I stretch this one at 3 pi halves down to -3, and I'm just going to slowly draw it in. Now I also know that my sine curve goes through at 0. I know at pi it goes through at 0, and at 2 pi it goes through at 0. So it doesn't have to be perfect. It should be a curve. I just need the general shape. I've got 5 points. I should be able to just draw it in, okay? So I'm just going to draw it in nice and curvy. Okay, and does go on forever and ever and ever if you want to do that, okay? So my amplitude is 3. What's my period? How wide is one curve?
3.
Well, let's check it out. That's the amplitude, but one curve is here. Okay. How wide is one curve? Cassidy, how wide is one curve? 2 pi. Yeah, that is the period is 2 pi.
Why does it say that 2 pi
Is going to be the period. So I want to talk about that now. You're ahead of me. I like that. So B, this number here, there's a number, invisible 1 right here, talks about the frequency. So the number here is always the frequency. How many curves do you have within its standard 2 pi? Frequency, b, the value of b, which is, we'll see when we're down here in example 3, okay, is frequency. We have one curve in our 2 pi, okay? So if you're not sure what the period is, you can always take 2 pi and divide it by the frequency, okay? We're getting there on example 3, okay? Good question. Thanks, Retta. Hang on to that question until we get down to 3, okay? All right, now, example 2. Everybody okay on example 1? I just took my standard sine and stretched it up to 3 and down to -3, right? Okay, now, example 2. It's a cosine curve. I'm going to take this cosine curve here, and how am I going to change it? It's going to be upside down. It's going to be like this. I'll show it again. It's going to be upside down, except it has an amplitude of 3. So the amplitude is 3. So I'm going to have to go 1, 2, 3, -1, -2, -3. I'm going to go pi halves, pi, 3 pi halves, and 2 pi. Those are the ones I really just need because that gives me my general shape. My period, we'll put that down after I graph it, okay? So I'm going to take this curve and I'm going to graph it upside down, but from -3 up to +3. So it's going to look like this. I'll draw it, and then I'll back up and let you take a look at the original. There's the original. It's oops, there's the original. It's upside down. Do you see how it's upside down? And it's stretched to 3 and -3, okay? So I changed its amplitude and I reflected it over the x-axis. Okay, so what's the, and of course it keeps going on and on and on and on, but what's the period? Yes, the width of one curve is 2 pi.
Is that going to be the answer for like pretty much everything?
No, let's take a look at example 3. Yes.
Is there a tangent way?
There is a tangent curve, yes, yes. We will study that in pre-calc, okay? Yes. We're going to try and keep it simple at this point because we're at the end of the year. We're just, in fact, most of the applications you ever get is a sine wave, okay? Heart rate monitor is a tangent. That's a tangent. But there are applications. Okay, now, if the frequency is B, that means I need 2 curves. Okay, I need 2 curves.
If it's not just x?
Correct.
So is it like the number in front of x is how many curves?
Yes. Cassidy, you should be teaching. You say the best things. So I'm going to take this cosine curve here, which is from 0 to 2 pi, and I need to fit 2 curves in here. So to fit 2 curves in here, I'm going to have to make it half as wide to fit 2 in. I'll say it again. I need to fit 2 curves in here. To make 2 curves to fit in here, I need to make it half as wide. So, Retta, the period, the new period, okay, the new period is 2 pi divided by the frequency. So that means my new curve would have a period of pi. Right? So let me go ahead again and put down my pi halves, pi, 3 pi halves, 2 pi. I use these angles because those are the ones from the unit circle. What's the amplitude of the curve I'm going to graph? 4. The amplitude is 4. So I'm going to go 1, 2, 3, 4, -1, -2, -3, -4, right? So, and I'm just going to give you a really rough sketch. This is a really rough sketch. Cosine looks something like this. Okay, there's my cosine curve. I just drew it on the side. That's my cosine. So I need to put this shape in pi, so I can put another shape in pi, so I get 1, 2 of them. Okay? I'm going to put this shape here and here, so I get 2 of them. Does that make sense? Well, when I graph them, I always like to take a look at the fact that there's 5 important points. On the cosine curve, there's the beginning, there's the end, there's the middle, and then the 2 quarters. So I'm going to do this. I'm going to do a dot to dot. Watch my dot to dot. Let me get a pencil that works. Getting that time of year when all my pencils are running out. Okay. All right. Just here, orange will work. So, starts at 4, ends at 4. At pi halves, it's down to -4. Here and here. Okay, I'll back up. Here's this shape within 0 to pi. Here's this shape. This is my cosine curve. And I put it between here. My dot to dot is beginning, end, middle, first quarter, third quarter. So it's just dot to dot, okay? Now I need 2 of them because I have a frequency of 2. So I'm going to do it again. I'm going to do the shape here. Okay, so here, ends up here, down here, here, here. There it is. And of course it keeps going on forever and ever and ever. One curve is this wide. So what's our period? What's our period of one curve?
Pi.
Good. And our amplitude was 4. Okay. How am I doing? Okay. All right. Turn the page. Nope, not yet. Okay, I'll wait for you. If I get my act together, I'll bring in an oscilloscope on Monday, and we can sing into it and see your voice wave.
No way.
Yeah, it's pretty cool. I'll try and set that up Monday morning so you guys can sing into it and you can see your voice wave. It's really cool. Okay, turn the page. Yes, I'll wait. I don't mind. I love that Valeria, Sophie, and some of you take wonderful, beautiful notes, so I'm willing to be patient, okay? Because they're beautiful notes.
You can change it.
Okay, now, what about example 4? 3 curves. 3 curves. So to get 3 curves in 2 pi, the period would be 2 pi divided by the 3 curves. So instead of going by pi halves, this time I'm going to go by thirds. Pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds.
Do you still just space it out by 4?
I like to. You don't have to, but for me, it's always been easier.
It doesn't matter then.
No, but I've found over the past that spacing by 4 makes it easier to move it, right? So I had to break it into thirds because I know I had to get 3 curves. I had to get 3 curves in 2 pi. So Retta, you asked a really good question. The period, the new period is always 2 pi divided by the frequency, right? Do you see what I just did? So I took my 2 pi divided by my frequency, and so each curve is going to be 2 pi thirds wide, this distance. So I'm doing a sine. This is what the sine curve looks like, okay? So let me, just on the side, draw a sine curve. It looks like this. That's a sine curve. I'm going to put 3 of these within 2 pi. I want to put 3 of these within 2 pi. So I'm going to put 1 here, 1 here, 1 here. I'll put 1 curve here, 1 curve here, 1 curve here. All right, now also it's upside down, doggone it, but it has an amplitude of 2. So it's really going to look like this. because of the negative, right? All right, and I'm going to go to 2 and negative 2. It's upside down, so I'm not going to draw this one. I'm going to draw the upside down one. And I like to put my 5 points in. For me, that helps a lot. Sine starts at 0, ends at 0. In the middle, it's at 0. It's going to have a point down at negative 2 and at positive 2, okay? Okay, there's one curve, and I'll let you get caught up. There's one curve, okay? See my dot to dot? These are my dots. There's my dots, okay? So there's one of 3. So I'll put in the others, okay? Second curve. Okay. And the period is, what's the period? What's the period?
Yes.
2 pi thirds, right? Period is 2 pi thirds.
Pi is 0.
Yes.
Is that like for everything?
You just need to get in this shape within here. In this space, pi is in the middle. Because pi is in the middle of the sine curve is at 0. I'm going to say that again, Cassidy. You need to get this shape in this space, right?
Yeah.
And this space in the middle is right there, okay? Okay, give me thumbs up when you're ready. Now, the next one's weird, but it's really the true application, okay? When you do sine waves, even on your phone or in your voice, you measure the x-axis in seconds. Does that make sense? Like 1 second, 2 seconds, 3 seconds. So these pi, they've got the 1, 2, 3, 4 in it, but you can't find it very easily, right? So watch what I do this one, okay? This one's going to be a better application of what we do with sines, okay? So if I take my formula for the period, okay? So my period is equal to 2 pi divided by b, okay? So my period of this one is going to be 2 pi divided by pi. Okay, 2 pi divided by pi, because b is equal to pi, right? And that just becomes 2. What this means is that every 2 seconds, you with me? I'll say 2 seconds. Every 2 seconds, it repeats. Does that make sense? So my axes are no longer going to be in terms of pi's, but like 1, 2, 3, 4, 5. So instead of pi's, my axis is going to be in terms of 1, 2, 3, 4. I'll spread it out a little bit so I can see it. So I'll go 1, 2, 3, 4, 5, 6, so forth and so on. My amplitude is 3. My scales are different, but that's okay. I can live with it, okay? Yeah. That's B. B. And B stands for the frequency. Yeah. B is the frequency. It's also the number there, okay? And then Sophia?
Yeah.
I wrote this somewhere. Oh yeah, right here. B is that number, which represents the frequency, okay?
I have a question.
Yeah.
If it's in the parentheses, if it's like pi x, is it always gonna like be going up by just like 1, 2, 3, 4?
Keep going with what you just said. So if there's a pi here, your axes will be in terms of numbers. If there's a number here, your axes will always be in terms of. Isn't that what you were saying, Cassidy? Yes, the answer is yes to that, okay? Okay, so let's graph this. So I want a cosine. Cosine looks like this. It's my water slide. I need this shape to be between 0 and 2, but a height of 3. So it's going to look like this.
Wait, why is it between, oh, like this thing?
There's one, and I'm going to keep doing more. That is one curve, okay? But I'm going to keep going, spacing of 2 seconds. Every curve every 2 seconds. A curve every 2 seconds, and so forth and so on and so on and so on, okay, right? And I like to highlight the graph. Period is 2, amplitude is 3.
Wait, why did we do three things?
You only need one, but I like to do a few. You don't have to. Retta, I just like to do a bunch. I like to think of it as a sound wave going on forever. Okay, all right. Now, last one. We're going to do the opposite. Here's a graph. What's the equation? Start with this. Y equals A trig bx. Okay, start with that.
And the trig meaning it's sine or cosine?
Yes, trig means either it's sine or cosine. Very good. Now, what is the amplitude? What is A in this example?
6.
6. Good. Everybody agree with 6? So it's going to be y equals 6. I agree. Now, is this graph,
I'm pretty sure it's 5.
I think it's 5?
Oh, yeah.
Okay, I'll go on with 5. I'll go on with 5. Red, I agree with that. Yeah, it's kind of hard to see. Now, a cosine, sine, okay? Which shape is it?
Cosine.
You could call it a cosine. I'm going to call it a negative sine. I'm going to call it upside down of that. Now, here's the thing. There are 4 correct answers. There are 4 correct answers. I could call it a cosine, but it's cosine got bumped over. We haven't talked about that yet. That's Monday.
Would it be a sine because it goes to the origin?
Yes. Think about it as a water slide or a roller coaster. So you start at the origin. Okay. So I'm going to call it a sine. I'm going to go y equals 5 sine. Now what is b? b is equal to 2 pi divided by the width. So to find the frequency, it's 2 pi divided by the width. The width of one curve. The width of one curve. One curve. One curve. How wide is one curve?
4 pi.
4 pi. So what is my b? 1/2. And this actually makes sense to me. I'll show you why. It's just, I'm going to blow your mind.
Wait, I have a question.
Okay, you ready? Just let me answer this quickly. Here's 2 pi, right? How much of a curve do you have? It's frequency. How much of a curve do you have? Half a curve. Half a curve. So the frequency is how many curves do you have in 2 pi? You got only half a curve. So the 1/2 makes sense, doesn't it? Bam! Yes. Ooh. Yes.
Oh, negative. That's what I was asking.
Yes. And one last thing, we better make it a negative. And there's my equation. Awesome. So what do you think? I'm going to stop recording, and we got a little homework to do. Yes.